To truly hear the shoreline, we must first understand it as a geological narrator, a relentless scribe inscribing Earth's history not in ink, but in sound and stone. Every time a wave gathers its energy, travels across vast oceanic basins, and finally expends that energy in a crash and subsequent wash over smooth stones, it is performing an act of immense physical storytelling. The very existence of those smooth stones is the opening chapter. They begin as rugged, angular fragments of cliff, mountain, or ancient riverbed, tumbled and ground down over millennia by the ceaseless, abrasive ministry of the waves. The sound they produce, that specific, rounded clatter and deep, grinding rumble beneath the foam, is a direct audio signature of their geological journey and composition. A shoreline of granite pebbles will sing a different, sharper song than one of basalt or limestone. The acoustic profile is a fingerprint. Scientists in the field of otoacoustics now use advanced hydrophones and spectral analysis to record these sounds, creating sonic maps that can tell them about the seabed composition, erosion rates, and sediment transport without ever diving down. But the story goes deeper. The rhythm of the waves themselves is a broadcast of distant weather and planetary mechanics. The interval between waves, their height, and their force are dictated by winds sometimes thousands of miles away. A storm brewing in the North Atlantic will, days later, telegraph its power onto a shore in Cornwall, translating atmospheric fury into acoustic energy. Furthermore, the gravitational pull of the moon and sun, the ancient clockwork of our solar system, is encoded in the tidal surge that raises and lowers the entire audience of stones, changing the frequency and reach of the wash. This means the soundscape of a shoreline is a real-time display of celestial mechanics. When you listen, you are hearing the moon's gravity pulling on the earth. More urgently, this geological narrator is now reporting on a new human-written chapter, climate change. Rising sea levels, a direct data point from satellite altimetry and tidal gauges, are changing the fundamental stage. As the water climbs, the wave energy is directed at new, often weaker parts of the coast, accelerating erosion in a feedback loop. The sound of a cliff collapsing a deep, booming crunch amidst the waves is becoming a more frequent punctuation in the shoreline story. Increased storm frequency and intensity, statistically validated by meteorological organizations worldwide, mean the narrator's voice is more often shouting rather than whispering. The consistent, gentle wash is being overwritten by violent, percussive blasts that move geology faster than ever in the recent past. The data from coastal monitoring stations shows a clear trend. The energy signature of wave impacts is increasing. So, that calming sound is actually a live feed of a planet in physical flux, a billion-year-old process now accelerating under human influence. The smooth stones are being ground down faster, cliffs are retreating, and the very map is being rewritten, all reported in a language of pressure, resonance, and frequency that we are just beginning to fluently understand. This isn't just background noise, it's the planet's heartbeat, and the stethoscope is pressed against the thin, dynamic margin where land and sea perform their eternal, conflicted dance, a dance whose tempo we have recklessly increased. Beneath and within the geological roar lies a more delicate, intricate, and critically endangered layer of sound, the biological symphony of the shoreline. This foamy, stony interface is not a sterile battleground of rock and water. It is a thriving, cacophonous metropolis, and every resident contributes to an acoustic tapestry essential for survival. The moment you filter out the wave noise, as marine organisms have learned to do, you enter a world of clicks, pops, grinds, snaps, and songs. The stones themselves are habitats. Barnacles and mussels clamped to their surfaces make microscopic settling and feeding sounds, a constant gritty static. Small fish like blennies and gobies dart in the shallows, their movements creating precise, liquid pulses. Crabs scuttle and grind, their shells clicking in a form of communication. This sonic environment is not incidental. It is a fundamental channel of data for these creatures. For many larval fish and invertebrates, the specific sound signature of a healthy rocky shore is a homing beacon. Studies from institutes like the University of Exeter have played recordings of thriving coastal soundscapes near degraded habitats and observed significantly higher rates of settlement and recruitment, proof that sound guides ecosystem restoration. The crackle of snapping shrimp, a dominant biological sound in many coastal zones, creates a broadband acoustic layer that can mask prey from predators or serve as a territorial marker. But the most profound data comes from the changes we are recording. The creeping crisis of ocean acidification, driven by the sea absorbing excess atmospheric CO2, with surface pH levels already dropping by 0.1 units. A 30% increase in acidity since the Industrial Revolution has a terrifying acoustic side effect. It changes the water's chemistry, making it more absorptive of low-frequency sound. This means the ocean is becoming acoustically brighter for certain frequencies, potentially disrupting how sound travels and how animals use it. Furthermore, the noise we add the relentless drone of ship traffic, the seismic blasts of oil exploration, the roar of personal watercraft is creating a smog of noise pollution that drowns out this biological symphony. Research published in journals like Marine Pollution Bulletin documents how chronic anthropogenic noise increases stress hormones in coastal species, disrupts foraging, and masks the critical sounds of predators and mates. The ecological soundscape is being simplified, homogenized, and silenced. A shoreline that falls quiet is a shoreline in ecological crisis. The loss of that rich biological chatter is a direct indicator of biodiversity loss. When you walk along a stony beach and hear only the waves, you might be standing in what acoustic ecologists call a ghost habitat, a place that looks the part, but has had its vital sonic soul extinguished. Protecting the shoreline, therefore, is not just a visual or chemical endeavor, it is an acoustic one. Marine protected areas that limit noise pollution show a rapid return of sonic complexity, a measurable metric for recovery. The foam washing over stones carries within it the dissolved breath of our civilization and the stifled voices of a hidden community. To listen carefully is to take a census, to hear the health of an entire ecosystem in the interplay between the abiotic crash of water and the biotic crackle of life. That symphony, millions of years in composition, is now being rewritten into a dirge by human activity, and the data streaming from hydrophones placed around the world is the sheet music documenting this tragic shift. Why does the sound of waves on stones universally captivate and calm the human mind? This is not a trivial question, but a gateway into a fascinating intersection of evolutionary biology, neuroscience, and psychology, with profound implications for our well-being in an increasingly frantic world. The data here is compelling and moves beyond anecdote into hard science. Functional MRI studies have shown that listening to natural sounds like waves triggers a cascade of neurological events. It activates the default mode network, associated with mind-wandering and restorative mental states, while simultaneously dampening activity in the amygdala, the brain's fear center responsible for the fight-or-flight response. The sound is processed as non-threatening, which allows our prefrontal cortex, the seat of executive function and higher order thinking, to recover from cognitive fatigue. This is why a walk on a beach can feel so mentally clarifying. But let's delve into the acoustic properties. The wave sound is what audio engineers call pink noise, or a variant thereof a sound where the energy distributes inversely across frequencies, creating a full, rich, and masking hum. Its predictable yet variable pattern, the build, crash, and wash, is rhythmic enough to provide a temporal structure, but random enough in its details to avoid becoming monotonous or predictable like a mechanical metronome. This specific acoustic profile is exceptionally effective at masking jarring, abrupt noises, like a door slamming or traffic, that trigger stress responses. Our ancestors, who found calm and safety near fresh water and food-rich shores, likely passed on a genetic predisposition to associate these sounds with security and abundance. Modern, Psychoacoustic research quantifies this. Studies measuring cortisol levels, heart rate, and galvanic skin response consistently show greater and faster reduction in stress markers when subjects are exposed to recordings of ocean waves compared to silence or urban noise. Furthermore, the negative ions produced by breaking waves, which we associate with that fresh, clean smell, are believed to interact with our biochemistry to boost mood, and the sound becomes an auditory cue for that entire beneficial environment. However, the modern twist is alarming. As we degrade the actual soundscapes, we commodify and simulate them. The multi-million-dollar market for white noise machines, sleep apps, and relaxation playlists is built on a synthetic replica of a natural experience we are destroying. There's a profound irony and tragedy in needing to purchase a digital recording of a healthy shoreline because the real one outside our window is acoustically polluted or ecologically dead. The data suggests our mental health is becoming indirectly collateral damage of coastal degradation. Access to natural soundscapes is now a matter of environmental justice. Wealthier communities can preserve or access quiet shores, while others are left with the stressful cacophony of industrialized coastlines. This sonic connection is a two-way street. Just as a healthy shore benefits us, our collective mental need for these places can be a powerful driver for conservation, framing shoreline protection not just as saving cute animals or pretty views, but as preserving critical mental health infrastructure, changes the policy conversation. That foamy, stony whisper isn't just a nice to have. It's a necessary auditory nutrient for the human psyche, a legacy sound that has shaped our nervous systems for millennia, and its degradation is a silent, creeping stressor on a global scale, a loss we measure in rising anxiety as much as in rising sea levels. The crisis facing our shorelines is often silent to our casual perception, but it is screaming in the data collected by a network of sophisticated instruments that form a planetary early warning system. To move from poetic concern to effective action, we must understand the tools that quantify the problem. This is where the story becomes one of technology, big data, and sobering trends. Let's start with the stones themselves. Satellite imagery with multispectral sensors and LiDAR, light detection and ranging, mounted on planes now measures coastal erosion with centimeter precision. Agencies like the U.S. Geological Survey and the European Space Agency's Coastal Change Program can show you time-lapse maps of a beach shrinking, a cliff retreating over years and decades. The data is unambiguous. A significant percentage of the world's sandy and rocky shores are eroding faster than they can be replenished. But what about the sound? This is where passive acoustic monitoring (PAM) comes in. Hydrophones, underwater microphones are deployed on buoys, fixed poles, or even on robotic gliders. They record 24/7, capturing the full soundscape. Advanced software then parses these terabytes of audio, using algorithms to separate the geophony, wave sounds, biophonic, creature sounds, and anthrophony, human noise. Scientists can track the migration of whale populations by their songs, monitor fish spawning aggregations by their choruses, and measure the constant background thrum of shipping lanes. Crucially, they can detect the absence of sound, the acoustic voids that signal ecological collapse. Concurrently, other instruments take the chemical and physical pulse. pH sensors track acidification in real time. Conductivity, temperature, depth, CTD. Profilers measure the fundamental properties of the water column, showing how warming layers can change how sound travels. Nutrient sensors flag pollution runoff from land. When you synthesize these parallel data streams, the acoustic, the visual, the chemical, a devastatingly clear picture emerges. They tell correlated stories. A coast with rising anthrophony and acidification shows a declining biophonic signature, an accelerating erosion. For instance, data from the Monterey Bay Aquarium Research Institute shows how ship noise directly correlates with disrupted foraging behavior in endangered species. The shoreline with foamy waves is one of the most densely monitored environments on Earth, not for its beauty, but for its diagnostic value. The global Argo network of floating probes, coastal radar systems, and citizen science water testing all feed into this understanding. The shocking revelation from all this data is the speed and connectivity of the change. A pollution event or a noise-generating activity doesn't stay local. It radiates, it dissipates, it adds to a global burden. The smooth stones on a remote Scottish isle are being shaped by waves' energy influenced by melting Arctic ice, and their interstitial creatures are stressed by a background chemical shift originating from emissions on another continent. The instruments reveal as Shoreline not as a postcard, but as a dynamic, suffering, interconnected node in a planetary system. This vast sensor network is our collective ear to the ground, or rather, to the waterline, translating the analog, ancient language of the coast into digital data points, trends, and projections. Ignoring this data is not an act of skepticism. It is an act of willful deafness to a million scientific voices, all reporting the same urgent dispatch from the edge of our world. Hearing and understanding this cascade of data leads us to one inevitable and empowering conclusion. We must transition from passive listeners to active participants in preserving the planet's sonic and ecological integrity. This is not about grand, unreachable gestures. It's about targeted, informed actions that collectively reshape our relationship with the coast. The first and most direct action is acoustic sanctuaries. We must advocate for and establish marine protected areas, MPAs, with stringent noise pollution regulations. This isn't just about banning oil drilling, it's about mandating quieter ship propellers, enforcing speed restrictions near sensitive coasts, and routing shipping lanes away from critical habitats. The technology for quieter maritime transport exists. It needs political and consumer pressure to be adopted industry-wide. Support organizations like the International Quiet Ocean Experiment or the Ocean Conservation Trust that lobby for these policies. Second, become a citizen scientist. Your smartphone is a powerful data instrument. Projects like NASA's Soundscape or the Freshwater Watch app allow you to record environmental sound or test water quality on your beach visits. This crowdsourced data fills gaps in official monitoring, helping scientists track changes in real time. Every recording you make is a data point in the global defense of these soundscapes. Third, consume with sonic consciousness. The choices you make inland directly affect the coast, the fertilizers on your lawn, plastics you use, the carbon footprint of your commute, all these end up in watersheds that flow to the sea, altering chemistry and ecology, which in turn alters sound. Support sustainable fisheries and businesses committed to reducing ocean pollution. Be aware that your online shopping, often shipped via massively noisy container ships, has an acoustic cost. Demand transparency and quieter logistics from retailers. Fourth, educate and propagate the sound. Don't just listen record. Share high quality, unedited recordings of healthy shorelines. Use social media to spread not just images, but the sound of a thriving coast. Create playlists for friends, titled "This is what we're saving." Invite people to close their eyes and listen. This builds an emotional, visceral connection that graphs and charts alone cannot. We are a species wired for story and sensation. Use that wiring for conservation. Finally, advocate with your vote and voice. Support coastal zoning laws that limit disruptive development. Push for investment in green infrastructure like restored wetlands and oyster reefs that buffer wave energy, dampening erosive sound, and create rich biological soundscapes. Write to representatives, making the case that a healthy coast is a national security issue, an economic asset for tourism, and a public health necessity. The call to action is clear. We must become stewards of the soundscape. The foamy wave washing over the smooth stone is a live broadcast from the front lines of the planetary environment. We can choose to let it become a relic. A sound, we explain to our grandchildren, existed once, like the call of the extinct ivory-billed woodpecker. Or We can choose to fight for its continuity. The tools are in our hands, the data is on our screens, and the path is marked by the very stones the waves polish. This isn't just about saving a pleasant sound, it's about preserving a fundamental thread in the fabric of a living, speaking, healthy earth. So, the next time you stand on a shoreline, I want you to truly listen. Hear the geological history, the ecological symphony, the ancient call to your own psyche, and the silent cry for help hidden in the data. Then, let that listening transform you. Start today. Pick one action from this video. Download a citizen science app before your next coastal visit. Research and donate to one organization dedicated to marine acoustic preservation. Have a conversation about ocean noise pollution with one friend. And most importantly, subscribe to this channel and ring the bell. Why? Because this conversation doesn't end here. In the coming weeks, I'll be diving deeper into every aspect we touched on, profiling the cutting-edge tech, monitoring our seas, interviewing coastal acoustic ecologists, and creating guided soundscape meditations to reconnect you with nature's frequency. I'm building a community of informed, active listeners, and your subscription is your commitment to being part of that solution. Together, we can amplify the message the waves are carrying. We can turn the tide from degradation to restoration. Hit subscribe, join the notification squad, and let's ensure that the timeless, vital sound of foam on stones never becomes just a memory, but a thriving, enduring testament to a planet in balance. The wave is coming in. What will you do before it washes back out?